This video is about Chapter 11, and in this chapter we'll talk a lot about randomness and how to use randomness. By the end of this video, you should be able to explain how randomness is a tool. You should also be able to use randomness to design something called a simulation. First, we define random to be we don't know the outcome before it happens. We may know the possible outcomes, for example, rolling a dice. You know that it'll be the numbers 1, 2, 3, 4, 5, or 6. You also may know the probabilities of each outcome, but you don't know what number it's going to be until it happens. That is why rolling a dice is random. Now, there are two places to find pseudo-random numbers, or kind of random numbers, as close as we will ever need to get. One way is using your calculator. On a TI-84, if you hit the math button, the very last tab is prob for probability, and number 5 on there is randint. Okay, it's a function that generates random numbers. Okay, so randint takes two variables, a left bound and right bound, and it'll give you one random number in between, I should say integer, in between those two numbers. Okay, now if you put a third parameter into that function, this is left bound. Let me write it over here. Left bound, then a right bound, and then this is how many numbers. Okay, so this function down here says randint, I want numbers between 1 and 6, and I want 2 of them. Okay, so you can use your calculator to generate random numbers. Okay, the second way is by using a table of random digits, like the ones in your textbook. Okay, it's a string of random digits. It passes tests. There actually are tests for randomness, and there are tables of random digits. Okay, you should be able to do both of them, especially my AP students should be able to use both of these to generate random numbers and use those random numbers. Now, we can use randomness as a tool. Many events in our lives are random occurrences, or at least we can think of them as random occurrences, like the time we arrive at a stoplight, or the time we enter a store, or the number of text messages we receive. We can think of those as random occurrences, and then we can use randomness to simulate and then analyze these events. Okay? Here's a situation from the textbook that may not be the most useful to you, as it has to do with finding athletes' cards in cereal boxes, but it models pretty well how to do a simulation. And then later on we'll talk about how to simulate something that is a little more useful and pertinent to you. Okay, so the situation is there are trading cards inside cereal boxes. 20% have Tiger Woods, okay, who's a golfer. 30% has David Beckham, a famous soccer player, and 50% have Serena Williams, who's a tennis player. Okay, now we're going to model this using a simulation. So the first component to a simulation is identifying the component that will be repeated. Okay, in this simulation, we're thinking of it as opening a box and seeing which card we have. Okay, now instead of actually opening, buying the cereal and opening the box, we're going to simulate it using randomness. Number 2, which is a really important component, because it shows up commonly on tests, is to explain how you will model the component's outcome. Okay, in this case, we're going to use digits from 0 to 9. Okay, and we'll do 0 to 9 because we can then use a table of random digits, and we will assign 20% of the numbers to Tiger Woods' picture. Okay, so I'll assign the numbers 0 and 1. That's 20% of the digits. I will then assign 30% of the digits to David Beckham. So I'll assign numbers 2, 3, and 4 to David Beckham. and then the last 5 digits, which is 50%, to Serena Williams. Okay, so in that case, I can just pick up random digits and simulate getting these cards and seeing how many it takes, and that's our third component. Explain how you will combine the components to model a trial. Okay, in this case, we're going to see how many numbers I have to get before I get one of each of these. Okay, in other words, how many boxes I have to open before I get all 3 athletes' cards. Okay, number 4, state clearly what the response variable is. Okay, I've mentioned this already, but we want to find out the number of boxes it might take to get all 3 cards. Okay, that is clearly, that is our response variable. Number 5, run several trials. We do this using several trials, and here's a string of random digits, and so we pick off, we just do, I guess they've done it for us. 8 is their first Serena Williams card. 9 is a second Serena Williams card, which isn't useful to us. 0 gives us a Tiger Woods card. We have 2 of them. Then we get a 6, which is another Serena Williams, and then 4, a David Beckham. We have all 3 cards, and it took us 5 boxes. Okay. The next is number 2 is a David Beckham card. Number 7 is a Serena Williams card. We have 2 of them. We then get another Beckham, which we don't need, and we get 0, which is Tiger Woods. It took us 4. Okay, and we can do this over and over and over again. And they did about 10 trials. And then after you do several trials, you then collect and summarize the results. Okay, we often look for averages, how many it took before we got what we wanted to. Okay, and then the last thing you do is you state your conclusion, and you do always in context. Everything we do in this class will be in context. Okay, and we can say that it took us a median of 5 boxes to get all 3 cards, but it could take a lot more. There was one that took 18 digits before we actually got the last David Beckham card. Okay, that is a simulation. Here are the 7 components one more time. You identify the component that will be repeated. You then explain how you will model the component's outcome, how you will assign digits, or what you'll do. That's a really important one because it's a common AP question. Number 3, explain how you will combine the components to model a trial. Number 4, state clearly what the response variable is. What are you looking for? Number 5, run several trials. Number 6, collect and summarize the results of all the trials. And number 7, state your conclusion in context. Okay, that is the 7 steps of creating and running a simulation. So this video was about randomness and explain how randomness is a tool, and also you should now be able to design a simulation. Thank you so much for watching.